Thank you, though. Thank you for inviting me to here. So this is my name, and from Australia. And after 9 top researchers, and I think it will be a little bit tight. And this top 9 researchers, 2 of them have H index more than 100. So you know who they are. And the other 7, I believe their H index more than 70. So I stand here, I feel a little bit ashamed, but my H index only 38. So it's too low based on that criteria. However, I'm very, very different from these 9 people because they're leading. They stayed front. I'm stayed behind. I'm the behind the scenes. So basically in the last 8 years, I service for all of you, not only few people. And first thing, I see how many people are retired because a lot of people have jet lag. How many people have jet lag more than 10 hours? And how many people have jet lag more than 15 hours? Okay, only myself. So I have 17 hours. So hopefully my last one, and probably a little bit more entertainment, and let you to wake up. And first thing, how many people go to Australia by attending ICDM 2010? Put your hand up. Okay, few. How many people attend KDD 2015 last year? Put your hand up. Okay, how many people never been in Australia? Oh, so okay. So my job is to give you a cues to visit Australia through the ICDM 2010 and KDD 2015. But if you haven't been there, a lot of people put a hand up. Don't be regret. We have a chance. Okay, next year, in the August, where date? Oh, date is somewhere. On top. So if you put hand up, you'll never be in Australia. This is the last chance. You go to Australia by me because I really serve it for you. And if you decide you go to Australia next year, after this meeting, pick up one cover paper, and 1 week before conference, you send me email, attach by scan this copy. You said, I attend your session, and then I decide to come to Australia, and next year, if you send me email before 1 week, I will give you a secret gift. If you don't attach this, no gift. So that means you heard from someone else. If you attach this, scan this copy, attach in your email, I will give you a secret gift. But after this one, you must pick up one, otherwise it's not valid. So that's why I said I'm behind the scenes to service all of you through the HDM 10, KDD 2015, EJK 2017, and this is my last conference. If you don't come, I never give you any more chance. So you can come, but not by me. So that's why I stay behind the scenes. At this date, just after 1 day from KDD next year. So KDD next year finished by 17 in the evening. Take a flight from Halifax, fly to Melbourne. And if you miss for 3 days, that's okay, because only workshop tutorial. Really conference start from 22nd. So you don't miss the real one. So that's first thing, I service for all of you. And second thing, I don't know how many people here, I have at least 10 assistant professors in US to get their green card. I don't know who are here. I saw someone, but I don't know someone here. But if you really need a green card, if you need my help, and send me email and for free service. No charge. Okay, that's my second service. My last service, that's why I stay behind, because I don't like 9 people. They're leading, they're running in the front. I'm in the behind. I just like, why am I stay behind? So I can show you. So I'm around the center for 8 years, you see, from 2008. And we get extension. And when the Dou said, I have a lot of money, and Yeah, kind of true, because now in our center, it's about $8 million per year. And we serve about 160 people. These 160 people only research, no teaching, no admin. And we graduate about 30 PhD per year. And that's why we spend about 8 million. So that's why I'm a person behind. I make all the people in front. And I think I cannot go to front. I only stay behind. So that is my job. Next thing, I like 3 BMW. So every people talk 3, but actually from 2011, I already have a 3 triangle. So because they mentioned 3, I just mentioned what is my 3. And one 3 is called philosophy of Zhang, my center. So I have a triangle from 2011. So first is brand strategy, talent strategy, governance strategy. So you can imagine if you cut any corner, it doesn't work. So I use this 3 triangle to make center very strong and very healthy. And next 3 called the art of leadership. Also, this is 1, and this is 2nd, and this is 3rd. Why this 3? Because when you think about the center or any leader, some leader really like, some leader really dislike. Why? Tell you why. But inside this rule, everything is clear, crystal clear, you can do. And outside is clear, you cannot do. And the secretary will look after inside and outside. What a leader look after? Leader look after green area. So good leader always make a green area go ahead. I take the responsibility. What is the leader don't like? Anything in the green, they said, don't do it. Then you can do nothing. Because all leader, all center, all organization, why they progress so fast? Because they can treat green area very well. You can go back to think about which leader don't like it, because they said everything not do. Only in the crystal clear area. That's the secretary job. So that leader should be fined because they have nothing to do. So all leader look after the gray area. Who can make good? Who is a good leader? And that organization can develop it. So that's my triangle and the 3 circle. So I really like his 3 BMW, but that's not worth that much money. So, but that's my philosophy and art of leadership for my center. So this is a current member for quantum computation. So you see we have 1, 2, 3, 4, 5, 6 professors. So we have a lot of professors. And for IS side, maybe you know some people name, and I heard a lot of people know, because this young guy have a H index 70, so he's qualified to talk about the research. And another associate professor, 41, and all of them is less than 40 years old. So that in my center is really good research. So my index only 38, so I can't put here because it's not qualified to stand here. That's why I said I'm only behind. Today I talk a little bit about his job. And because I'm not in France, so I talk to someone in my center, and I build a platform that they do research. So I will quick go through, even a lot of topic about every part, I just quick go through to get some idea, but not detail. And first thing about the graph, in this morning, we already see the keynote. They talk about graphics everywhere. That's true. And second thing, we said challenge. Challenge, you can imagine, wow. That means they have a lot of opportunity. Without the challenge, without opportunity. So from here, you can see every part is quite complicated for graph. And so in our research, we summarize the graph as a system, I can quick go through, as 5 layers, from environment to computing model to primitive computing paradigm query, mining, and application. So that's our summary for 6 parts. And interesting is, in the early stage, we use like a binary code and assembly language, and we treat the system, compute very clearly. And later, when we have a database, we say, we forget about compute system. But now, we come back again. We will think about compute system. What kind of computer science model and distribute or multi-core, you need to think about the redesign program. So we come back again. So in that case, you see, the first thing talk about the graph matching. And in this case, if two graphs match, find the subgraph. And another is a subgraph to talk about how many subgraphs in this big graph. And both problem is NP hard problem. So that's why the two problem is very, very hard. And in our center, we have done some good job and have 4 publications. And most recently is 2014. So that is partly of a graph. Another is locally dentist subgraph. For human, it's very easy to look at dentist. But for the computer, it's not as easy. But we got last year 1 paper in the KDD 15. By the way, last year I'm the general chair, not the program chair. So I'm qualified to submit the paper. If I'm a program chair, then I cannot not qualified. Because general chair never touch program. You never know how many papers submit, what's review. So that's qualified. If you become program chair, never submit a paper. That's hidden rule. For graph mining, we just give one example for graph classification. From graph database, they need 3 steps. First, generate a subgraph, then optimize subgraph, then get classification. That's early work. And then we try to simplify step 1 and step 2 together. Just use 1 step. Then we get classified, we get Scikit 12. Then later on, we just merge 3 parts together. Then we get make the iterative. Then we get a pattern recognition 15. So let's talk about classification and other work. We totally have 1, 2, 3, 4, 5, 6, 7, 8, 9 papers in this area. And some good like EGK, ICD, and also another EGK. So in the mining, we have done quite a number of work. This is 2 PhD theses. And here I only can talk a few minutes because before you sleep, and just quick go through and keep you awake and also probably hungry. It's already 6 o'clock. For query processing, I just briefly mention about diversified graph search. And so that is several work we work on this area. I just give one example for the graph. If we talk about some criteria with the top of 6 answers based on the density. But this answer is all concentrated this area, but we didn't cover this area. If we have another criteria that density plus the coverage, then the result will be called diversity, can be different. You see, from these 6 answers, and density is not as good as this, but the coverage must be much better. So that is like the graph, diversified graph search. So here we have 5 papers in this area. Graph processing system design. So this system design, as I mentioned, we have 5 layers, 6 parts, and that's just include. You see, from even input-output efficient computation, for database, we never worry about this. But when we come to big data, they become the issue. You see, traditionally, we only care about these 2 parts, from the cache to main memory. But in big data, we care about these 2 parts, from main memory to second memory. But how can you improve input-output? So that is become big issue. And so that's why when big data come back, we go back to early work to balance these 2. So in this balance these 2, and you need to consider main memory was the disk, and the sequential input-output and random input-output, and external was semi-external, because you never can put in the main memory. So that's become the issues. And every issue have a specific problem. So after you solve any problem, they can have a publication. So in this case, we have 1, 2, 3, 4, 5. We have 5 papers solve this problem. So for parallel computation, that's why we say we come back. If the multi-core is like this structure, if you have distributed computing, and we have this structure. But this two systems model, you need to have a totally different algorithm. For example, we can compare. For multi-core, you care about computation sensitive because they divide by task. For distributed computing, it's data sensitive. You divide by date. So here you try to minimize the communication. Here you try to minimize the task scheduling. So in that case, you see, you need to design individual algorithm to solve based on different system. So that's why you say that reduce cache means that reduce communication. So different system, you need to design different algorithm. So here we have 3 papers, and basically we solve some problem, but still have a lot more problem. For future research, we can see a lot of topics we need to do, but objectively we have 3 objectives, and each one is very difficult, and like the challenge for here, and this is another challenge, and this last challenge. So all the 3 objectives is very, very hard to meet because they have a lot of challenges. And for future work, let's just give you a summary. So in this 5 part, we publish about 50 papers in this graph. So later I have the list of papers. For future development, we still have a lot of area need to go ahead, like a social network recommendation. And when data become bigger and bigger and a lot of new problems come up, and location-based on social network, especially like a WeChat, you need a lot of location-based, and big graph processing in the cloud, and like a massive graph matching, that's even difficult. And another one is the graph summary. I think this is very important because graph have different granularity. Graph stream and personalized community search, high influence community search, graph clustering in cloud. Even every problem have solved, but still a lot of left. Massive uncertain graph, this is even more difficult. And then you can see the dot, you can imagine. And still have a lot of PhDs can do, and still can publish a lot of papers in the area. And in the conclusion, we can see big graph, now it's large, more complex, more challenges, and more opportunities, and more job opportunity. So for the PhD graduate, you still have a lot more job security. This is acknowledgement for, this is one our senior lectures, and this is our 2 postdocs. And these 3 people have joined, have about 50 publications here, and just list here. So, and then I save the time for the enjoy your dinner. Thank you very much.